Alright, example 4.2 says we have an airplane flying at a constant elevation overhead at 4,000 feet. A man is viewing the plane from a position 3,000 feet from the base of a radio tower. The airplane is flying horizontally away from the man. If the plane is flying at a rate of 600 feet per second, at what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? So the first thing I want to try to do is sketch a picture of this. So we have a man, an airplane, a radio tower. The airplane is at a constant elevation of 4,000 foot. We're interested when it's over top of the radio tower. And the distance from the man to the plane would be like the hypotenuse of the triangle, the S. The distance from the man to the tower we're just calling X. We want to know what is the rate, the distance between the man and the plane is increasing. So we're needing to know the derivative. So after we have got the picture drawn, the next thing we're going to do is try to define what those variables are. So we need to find ds dt. We're given dx dt is 600 feet a second, the rate the plane is moving, because it's moving left to right, the x direction. We're finding ds dt, and we're finding that when x is 3,000 feet. Alright, next step, trying to write an equation, going back to Pythagoras. X squared plus the 4,000 squared will equal the s squared. After we get our equation determined, depending on whatever context we're in, then we're going to differentiate. So 2x dx dt, the constant is going to disappear, 4,000 squared, because derivative of a constant is 0. Then we have 2s ds dt. We can divide by the 2 just to simplify this up a little bit, since it's a constant factor on both sides. Alright, now we're going to try to substitute in things that we know and start solving. So we know that 3,000 feet's x, we know that 600 is dx dt. We know we're finding ds dt. S is not given. We need to go back to the triangle for just a minute, plug in 3,000. If I have 3,000, 4,000, I can do Pythagorean, or I can remember our special right of 3, 4, 5. So that has to be 5,000. So that I can fill that back in. When I solve, just divide by the 5,000. I'm going to get ds dt is 360 feet per second. And that's all we got to take care of. That's what we want to find. One word of caution. If we substitute before we take the derivative, it causes issues. Everything really starts to clean up and simplify too fast. So when I put in the 4,000 before I've taken the derivative there in step 3, and now I take the derivative, it gives me 0 equals 2s ds dt. Cleaned out the whole side. I don't have anything really to work with, which tells me the ds dt is 0, and we know that if the train is traveling 600 feet per second, it's getting farther away from the person, so that can't be realistic. All right, so that's just a common Pythagorean type problem with related rates.